Hello, and welcome to the Clarity LIMS NovaSeq demo. When you first log into Clarity LIMS, we're going to first add samples to a project so that we can start pushing samples through the workflow. By clicking on Projects and Samples, it will bring you to the Projects view. The next thing that you're going to do is select New Project, which is the blue plus button. You need to give your project a name, and you need to give your project an account and a client. You can use these two fields however you see fit. Once you've added all of the mandatory fields, you can click Save. You'll then see that your project appears on the list on the left-hand side. To get our samples into the system, we're going to use a template today. Here you can see we have our 12 samples under the sample name. We've given them a container type, which is a 96-well plate, and we've given our container a name and our samples an associated well. Once we save our template, we can go back to Clarity and upload sample list. From here, we'll choose the file that we just saved and upload it back to the system. If we scroll down, we can now see and confirm that 12 samples were successfully added to our project. We're now ready to add them to an activated workflow. The first workflow we're going to use is the library prep validation. By clicking Assign to Workflow dropdown, you can go ahead and select the appropriate workflow that these samples should be assigned to. You'll then see that our samples are tagged with the appropriate workflow tag under the workflow column. We're now going to change back to the lab view. And these blue bars are our protocols. We can see our 12 samples are sitting in the library prep validation step in the library prep validation workflow. When we're ready to do the work, we can click into the step. This will bring us to the queue view. Here we can see the samples that are queued up and ready to have work done to them, and we can expand them out and see the sample details of the container. For today, we're going to add the entire group to the ice bucket, so we'll click the Add Group button. Once all 12 of our samples are in the ice bucket, we can click View Ice Bucket. From here, we'll have to select the indexes that we're going to use on this specific prep, and you'll see that under Label Options. Today we're going to use the AmpliSeq CD indexes, and we're going to plate our samples into a 96-well plate. From here we can select Begin Work, and this will bring us to the Place Sample screen. We're going to choose to plate our samples by column by selecting that in the placement pattern. We're going to select all of our samples and drag and drop them over. You do have the option to change the barcode of the plate if you choose to do so. We're now ready to add our labels. On the Add Label screen, we're seeing the indexes that we selected in the preview, in the queue view where it said Add Labels. So what we're going to do is grab all 12 of our labels and drag and drop them over to our 12 samples. It keeps a tally of how many times the index appears on your specific plate in these gray circles. There is also the print sample list, which will appear on every indexing step. It shows you which indexes are being plated into which well and which samples are in which well. You can print this out and bring it to the bench if you choose to do so. Once all of our samples are plated and indexed, there is index validation on this screen, where if you were to drag and drop another index onto a sample that's already been indexed, you'll see the error, sample has a reagent assigned. So this means that you cannot assign 2 indexes to one well. Now we can move forward into record details. And what we're going to do here is select the sequencing instrument, which in our case today is going to be the NovaSeq 3.0, and apply it to all of our samples. We're also going to give our samples a molarity in nanomolar, as well as a normalized molarity in nanomolar. Once all of the mandatory fields have been filled in, we can go ahead and click Next Steps. An automation is going to run to automatically set the next step to remove for us. This is going to ensure that our samples are going to be removed from this workflow and properly routed to the NovaSeq workflow. When we click Finish Step, a routing script is going to be triggered, and it's going to route our samples to the appropriate sequencing instrument protocol. So here 12 samples are routed to the NovaSeq 600V 3.1, and they're in the Define Run Format step. When we click OK, we're going to be brought back to the lab view, and we'll now see our 12 samples are sitting in Define Run format, waiting to have work done to them. If we click into the step, we'll be greeted with the Q view again, and we can see that our samples have been sitting there for 0 minutes. We're going to add the group to our ice bucket and view the ice bucket. We don't need to place our samples here, so we can move right into Begin Work. Here it lets us know that we need to add the flow cell type and the loading workflow type. Our loading workflow type is going to be standard, so we can apply it to all of our samples. The flow cell type is going to be SP, and the final loading concentration in picomolar is going to be 600 for today. Once we've added all of the mandatory fields, we can select Next Steps, and another automation is going to run to remove the samples from the workflow so it can be properly routed to the NovaSeq standard protocol. When we click Finish Steps, the routing script is going to run, and it's going to send these samples to the NovaSeq standard protocol. Here we can see 12 samples were sent to make bulk pool for NovaSeq standard. When we click OK, we're going to be brought back to the lab view, and all 12 of our samples are in the NovaSeq standard protocol in the first step, Make Bulk Pool for NovaSeq standard. We'll click into the step, and this will bring us to the Q view. Our samples are sitting there for 0 minutes, and we can add the group to the ice bucket. When we view the ice bucket, we only have one option of a destination container of a tube because we're going to be making a pool. Here is the pooling step, where if we wanted to, we could add 2 pools to this screen if we wanted, but today we're just going to make 1 pool from our 12 samples. I'm going to select all 12 of the samples and drag and drop them over into our pool. You do have the option to give your pool a new name if you wanted, otherwise it will just stay as pool number 1. In Record Details, there's a validation script that's running to ensure the input flow cell type and the pool type. Here we have a few mandatory fields that need to be typed in. So first is the number of flow cells to sequence. Today we're only going to sequence one flow cell. And then the percent of phi-x to spike in if you're going to use phi-x. Once you're done, if you wanted, you can click the pool icon. And what this will do is show you the number of samples that are currently in the pool that you have created. You can click the X button to close that out. And then you can click the Calculate Volumes button to do the calculations to calculate the RSB needed, the volume of the pool to denature, the NaOH needed, and the tris HCl volume. After the automation runs, it's going to calculate the RSB volume needed, volume of the pool to denature, and a CSV file is going to be generated. We can see at the top of the screen that the CSV was calculated successfully, and under the calculation file, you can choose to download the CSV if you wanted to take a look. It will always be attached to the step if you needed to reference it at a later time. But what we see here is the name of the samples, the volume of each sample, the volume of phi-x needed, the RSB volume needed to add to the pool, the volume of the pool to denature, the NaOH, and the tris HCl. Once all of the mandatory fields are filled in, you can click Next Steps, and the next steps will be automatically selected for you in the Set Next Step screen. Here our samples are going to move into dilute and denature, so we can click Finish Steps, and we will be brought back to the lab view. Now our 12 samples are made into one because we now have a pool of 12 samples. We can click Dilute and Denature to get back into the Q view. We'll see that our pool is waiting for 0 minutes. We can add the pool to the ice bucket, view the ice bucket, and now we're going to be plating our sample into a library tube. We can click Begin Work. We can plate the pool into the library tube. And here we're going to need the exact library tube that is on the tube in the NovaSeq kit. There is a validation that will run to ensure that you have the right formatting of the library tube typed in to the container ID. We can now move forward into Record Details, where the validation of the library tube barcode will run to ensure that you have the right formatting. And here we're going to have to log in the reagent lot tracking. So these lots were pre-accessioned into the system. If I had a scanner hooked up to my computer, I would go ahead and scan the lots right from each container, but we're going to scan in the NaOH, the RSB, and the tris HCl. We're then going to have to fill in all of the mandatory fields so that they can be populated on the sample sheet. We're going to give our project and experiment name. We're going to select dual index. We're going to select false for pair end. We're going to select no for all of the custom read primers. We're not going to use the reverse complement. We're going to select run monitoring storage. We're going to select 10 for read 1 index and 10 for read 2. We're going to select 75 for read 1 cycles and 0 for read 2 cycles. We then need to plug in the output folder. And now we can go ahead and click the automation to validate run setup and generate sample sheet. The green box at the top of the screen indicates that the sample sheet was generated successfully. The sample sheet is named to the same name as the library tube, and we can go ahead and download it and take a look at it just to confirm that everything looks the way that it should. And the sample sheet will also be attached to the step in case you need to refer to it at a later date. So all of the information and the indexes that were assigned at library prep were pulled in to our sample sheet. So now we're ready to move forward. From here, we're going to select next steps. And automation is going to run to preset the workflow, preset the next step to remove from workflow. And now we can finish the step. At the end of the step, our samples are going to be routed to the automated NovaSeq run step. And here we can see they've been routed to the automated NovaSeq run. We can click OK. And we're brought back to the lab view. So here we have our automated step, and just to confirm that our library tube is there, pool 1 has been waiting for 0 minutes. And what we would do next is go ahead and start the run on the NovaSeq, and it will automatically start this step in Clarity for you. can toggle back over to your Clarity LIMS instance. You're going to want to log in and then sign in. When you log in, you're going to be greeted with the lab view again. And it may not look like anything has happened, but after a few minutes of the run being started on the NovaSeq, what you should notice under recent activities is there will be an API access started step. You can see it up here at the top. Depending on how many steps are started and completed in the system, this could run through rather quickly. But if this is the most recently started step, you can click in to the step right from the recent activities. This will bring you directly into the record details screen, which has been automatically started by the API when the run was started on the NovaSeq. If we scroll down, what we'll see here is the buffer cartridge, the cluster cartridge, and the SBS cartridge all have been automatically updated to our reagent lot tracking. If we scroll down, what we will see under step details is some information that has been pulled directly off of the NovaSeq back into your automatically started step in Clarity. If you scroll down a bit further, what we see here is any type of sequencing logging. So this is all of the logs that come off of the sequencer. If you expand out your library tube, what you'll see is the lanes of each of the samples in the pool. You'll see your container name. And as of right now, since the sequencer is still completing the run, all of these metrics are going to be blank until the run is completed.